Let's talk about the relationship between the fish measurements and their weights from the fish market dataset. So I created a series of scatter plot, and each scatter plot represents the relationship between the weight of the fish and one of its measurements, length 1, length 2, and length 3, and height and width. And each scatter plot shows the relationship between the fish weight and one of its measurements. So to better visualize this relationship, I also added a trend line to each scatter plot. These plots show a positive linear relationship between the weight of the fish and also its length. So it means as any of the length measurements increase, the weight of the fish tends to increase as well. And the trend line further emphasizes this positive correlation. So similar to the length measurements, both height and weight of the fish exhibit a positive correlation with its weight. As the height and weight increase, the weight also tends to increase. These relationships are crucial for building a predictive model because they indicate that all these measurements are potential good predictors of fish weight. So a linear regression model could be effectively utilized here as the relationships appear linear. So incorporating these measurements into a model could allow us for accurate predictions of a fish's weight, which is based on its physical dimensions, which could be valuable for both commercial fishing operation and biological studies. So this visualization helps us in understanding the importance of each features in predicting the fish weight and assists in the initial exploration for building a predictive model. When we choose to exclude categorical features like species from a predictive model which focused on continuous data, it simplifies the model, but potentially at the cost of predictive accuracy, since different species of fish can have significantly different weight profiles even for similar length and height measurements, which including the species features that can provide very valuable information, which can enhance the model's ability to predict weights accurately. This is a graph which is showing the distribution of weights for one species, which is bream in the dataset, and we're comparing it with a distribution of weights across multiple species, which is a combined group of various other species. So this comparison will help us to clarify the impact of excluding categorical features like species from our analysis. The bream species tends to have a higher average weight when compared to a broader category of other fish. This highlights the variability in weights that can exist across different species, even within the same size measurements. So just by not including species feature in the model, the variability caused by different species characteristics is ignored. So this can lead to inaccuracies because a model trained in a combined data might have not accurately predicted the weight for a specific species like bream. Excluding the species features simplifies the model, which can be beneficial for us to understand the fundamental relationship between the physical measurements and weight, and without the complexity introduced by the species difference, right? However, this simplicity comes at the cost of losing potential crucial information that could enhance the model's predictive accuracy. So in predictive modeling, including categorical features like species helps us tailor the predictions to some specific groups within the data, which is critical when these groups have inherently different characteristics that can significantly impact the target variables, right? Like the weight of fish in our example. This is a scatter plot which is showing fish weight against one of the continuous features length 1 and color codes the points by species, which is a simple data set that includes multiple species and show the variation in the weight across species at the similar body length. It visually depicts the relationship between a fish's length 1 and its weight, and separated by species. And each species, bream roachpike, is shown in different color, which indicated that we have distinct clusters, and these clusters indicate that for similar lengths, different species have different weights at the same length 1. So for example, the pikes tend to be heavier than roaches and brains. The weight distribution across the same lengths shows significant variance by these species, which underscoring that species is a stronger predictor of weight, and incorporating the species into predictive model would likely enhance its accuracy just by accounting for these inherent differences. So despite its predictive model, the categorical feature species is excluded for simplicity sometimes. So this choice simplifies the model and focuses only on numerical features. However, excluding this feature might result in a less accurate model because it overlooks the biological differences between the species that might impact the weight. This graph helps us illustrate why sometimes simplicity is chosen over maximum predictive power, which is totally depending on specific goals and constraints of your study, right? So in summary, while excluding the species feature will simplify the modeling process, but incorporating it would provide a more nuanced understanding and potentially higher prediction accuracy due to the significant variance in weight across species for similar body lengths.